Thank you again for coming. This poor guy's been traveling all over the world, and he still made time for us, so thank you.
Sure did. What's up?
It's great to see you.
Likewise.
So I'm just going to give the crowd a little bit of a background. Baiju was the co-founder of Robinhood. If you are not aware, stepped away from his job as chief creative officer last year to start a space company. That company, Aetherflux, just recently raised $50 million and plans to launch its first demonstration satellite in 2026. What makes this whole thing really interesting to me is your approach, and I guess your investors too. While traditional space solar concepts have focused on these big geostationary satellites using microwave transmission, Aetherflux is building a constellation of smaller satellites in orbit using infrared lasers, which is a technology that most people have had. You say that coming at this as a sort of an outsider is giving you a perspective that is actually an advantage. And you're also positioning this as a defense tech company, which I also think is really interesting. But first, you had told me something personal that I thought was really interesting. And not syrupy, but which was that your dad was sort of an inspiration for this kind of massive left turn that you just took. So I wondered if maybe we could start there.
Yeah, absolutely. So this kind of speaks to my love of physics and math and all things space. Came from my dad, and I feel like, for me at least, the journey of starting a space company was preordained in some ways. My family moved to the U.S. from India shortly before I was born, because my dad had been applying to graduate programs in physics in the United States for like 10 years. And he said he was going to devote his life to science. He was not going to get married. He was not going to have children. He was going to pursue physics. And that didn't really work out for him. And so my mom, when she came to the U.S., was actually pregnant with me when she got on the plane. And growing up, my dad worked at NASA as a research scientist through my whole childhood, and he was very adamant. He's like, look, when you grow up, I'm not going to tell you should study physics. I'm not going to tell you should do these things related to science, which is a very effective way of convincing somebody to do exactly that. And so a little bit more here, right? So when I left the house, went on to study physics and math at Stanford, where I met my co-founder of Robinhood, a guy named Vlad Tenev. And I remember also sometime during that period, I read this book called The Case for Mars. Show of hands here if people know what that is. All right, we got one dude in the back. That's right. It's actually, I think, the book that was kind of the blueprint for what would become SpaceX in a lot of ways. It was this other approach to doing space other than the NASA, big government, sort of like really, really expensive approach that kind of asked the question, if you actually wanted to go to Mars, what would be the real engineering approach? And it talked a lot about reusable rockets as kind of the core technology, so on and so forth, this sort of like make things cheap and disposable. And I remember reading that and thinking to myself, like, man, if I ever hit it big at this finance thing, I think that's something I'm pretty interested in. And so it was, a lot of different things along the way. But honestly, coming back to what I was saying a little while ago, it was my dad that kind of really inspired me to do this. Yeah.
Yeah. Well, I guess I was just wondering, you mentioned, SpaceX. I mean, Elon Musk, I think, is another person who's inspired you, who's done so many different things across so many different realms. Was there a moment when you thought, I don't have to do fintech forever? I mean,
was there a moment where I thought I didn't have to do fintech forever? I mean, I approached it from the point of view of seeing a system that I thought really needed to be changed, right? I mean, that was kind of, we called our company Robinhood, for God's sakes. Actually, first of all, show of hands here. Who here uses Robinhood? All right. Show of hands here. Who has worked at Robinhood? Oh, hey-o. We got some alum in the crowd. Sorry, that was I got a little distracted.
It's fine. A lot of Robinhood users.
Yeah, and some former employees, too. So remind me again what I was talking about.
No, I just wondered if there was like a moment where you're like, because you did found this company that's a publicly traded company. You're a billionaire. Like, you didn't have to start a space company. So I just wondered if there was sort of a,
Yeah, I'd been thinking about it on and off for years and years, and kind of asking myself, especially when the reusable rocketry happened, right? When SpaceX landed a rocket on its butt and didn't blow it up. I remember thinking to myself, I'm like, this is like, at some point, if the space race happens again in my lifetime, I'm like, I really want to be a part of this. Lo and behold, I actually stepped back as CEO, co-CEO of the company along with Vlad shortly before IPO. And it was, I would say, sort of like beginning of last year, a little bit towards the end of the year before, so like end of 23, beginning of 24, where I had been in my spare time doing a little bit of research on this topic of space solar power. And that's when I was spending a lot of time with this group, DARPA, that's doing power beaming. And that's kind of where I realized that this approach, like you mentioned earlier, of using infrared lasers for power transmission, that there was actually a decent bit of work that had gone into that, and that there was an approach there that, for me, what was interesting was a way to actually do space solar power. And I can actually, I don't know if it'd be a good time to talk about what space solar power is.
It'd be a great time, and it would also be a great time to explain why lasers over microwaves.
Yeah. So what is space solar power? The idea is that the sun is a truly abundant source of power, and that there's ways of harvesting it that might be better. And it was an idea that was born in the 1970s, coincidentally, when the energy crisis was happening, of these future energy sources. And the idea called for collecting solar power in orbit, sort of outside of the atmosphere. And depending on which orbit you put it in, you can generate power continuously or a large chunk of the time. Again, depending on which orbit you're in, how high up you are, so on and so forth. And the benefit of that is that you get sort of higher power density per unit area in space, and you can actually transmit that power down. And the benefit of that is that you'd be able to generate solar power on the ground, daytime or nighttime, right? You'd be able to generate it and kind of achieve this sort of lofty goal of being able to have sort of base load power from solar. And so what this idea called for was building a big, beautiful array of microwave antennas that would all sort of phase coordinate and focus a beam of microwaves that you could point down at the ground. The problem that I saw with this is that everything was too big. Like the size of the array, the size of the spacecraft was the size of a small city, right? And that's like real science fiction stuff. Now, the approach that we're taking is actually fundamentally different because the way that we transfer power is different. So instead of using little antennas and modulating the phase to focus a beam, we actually use infrared fiber lasers. So who in this audience knows how lasers work? Show of hands. All right, yeah, that's a pretty good number, actually. Lasers are basically like engines. They take one kind of light and they produce a different kind of light. And in our case, we take the solar power that we collect from the sun with solar panels, and we take that energy, that electrical current, and we put it into a set of diodes that then take that energy and turn it back into light. That light then goes into a fiber where there's a laser, which then lets us point that down to the ground. The benefit of this is we can do this with a pretty small spacecraft to demonstrate it. One, and two, the spot that we see on the ground actually becomes pretty small. So to kind of put a finer point on the first one, we're launching a satellite next June and another one later on next year that are actually going to do this and are going to demonstrate space solar power that to date has not really happened, right? Like, this is not a thing in the world. This is like something that's in the pages of science fiction and in a bunch of random DARPA specs. Yeah.
And I think, well, one thing that you told me that I thought was really interesting and arresting was that the U.S. is going to be awfully glad that you proved that this technology is feasible. So, speaking of, I guess, the government, the DoD is one of your investors. You've got a guy who's written about Paul Jaffe, written about power beaming, who's sort of a confidant of yours. I guess, what does he say about what you're building? And I guess how much does it matter that DARPA is paying attention to what you're doing?
Yeah. So one sort of minor difference. So we're actually, our program has been approved for funding by the DoD. So they're not investors, but it's more like a contractual thing, grant contract, somewhere in that realm. And like you mentioned, we've talked to a lot of folks in the government that are working on these technologies, and in particular, this group out of DARPA led by Dr. Paul Jaffe, who's become a pretty good friend of our company. He works with us, and he works with other companies that are doing this as well. And the reason I've spent a lot of time with him is because he's taken this rather esoteric thing where it's not just a lot of physics that goes into it. It's sort of like on the cusp of what the engineering that's possible to do it today is, and has really helped us he's been a sounding board a lot of the times as we're thinking about different designs of our power transmission. And as a matter of fact, I would say that the way that we've designed this first demonstration is in many ways inspired by programs that he's done. And what I'm trying to say there is the idea of being able to project power down to a really small receiver is something that the government cares a lot about, in particular the Department of Defense. The reason they care about this, and sort of like the thing that connects the dots here, is it allows the U.S. to have energy out in the battlefield, think forward deployed bases, and it doesn't have the limitation of needing to transport fuel, right? So your power generation is this decentralized constellation of satellites in low Earth orbit that are each generating power. And if you've got a receiver, our target at first is going to be, bigger than 10 meters diameter spot on the ground, but we think we can actually get that smaller, 5 to 10 meters, potentially even smaller than that. That allows you to have these small portable receivers that ideally are relatively lightweight, that ideally are of little to no strategic value if captured by an adversary, where they're small enough and they're portable enough that you can literally bring them out into the battlefield, connect a satellite in space, and get real meaningful power that you can use. So that's kind of the vision that space solar power has. Should I just shout? I'm happy to shout. And as it relates to what we're trying to do as a company, we want to make space solar power a reality. The mission of our company is to deliver energy to planet Earth. We're trying to build an energy company. And if you kind of look at the history of important things that have happened in space, take, for example, like GPS, right? That was a DARPA thing. That was a DARPA idea, if I'm not mistaken. And so there's this precedent of doing stuff in space. There's a really important part of working with the government. But we actually think over time, as the technology matures and things like Starship really open up commercial access to space, that this is not going to be just a Department of Defense thing, but there's an opportunity to build a true industrial scale, energy company.
That's exciting. I mean, so you sort of start as national security infrastructure, but then you become sort of a broader renewable energy play. So you mentioned that, at Robinhood you could iterate. You roll out a feature, it doesn't work, or people love it, or somebody tells you to stop, showing people confetti when they do a deal. But here you have, there's a lot riding on this. And you've got this demonstration that's coming, pretty much around the corner. I think you said next June. So how do you kind of pressure test what you're working on?
Oh, that's the fun part of it, right? As an entrepreneur, I'm serious, that's the fun part, is doing something that is hard. Doing something where that the probability that it succeeds is not guaranteed, right? But if you work really hard, you hire the right people, you think through the problems deeply, you ask the questions early and answer them, you have a chance of doing something really, really meaningful. And so to answer your question, like how do you do this, the development here is really different than building mobile consumer financial services products, right? Like we're building real hardware, and there's this balance between simulating different parts of the system and actually building the hardware to do it. Right? And these are things that kind of understanding from first principles, understanding, like you said, as a novice, learning the sort of, actually the right thing to do is not to wait until you're totally done with all of your designs to start manufacturing stuff, but to actually have those two things that, if you kind of think about it, in a perfect world, you'd have your designs done for whatever you're building, and then you start building it, right? I think the right way to do this is actually to have that whole process be much more integrated. I'm going to give you an example, kind of like how you do this. But the end result, kind of, what is the finished product and what does the finished product working or not working look like? It is fundamentally different because we build one spacecraft, we bolt it to the fairing, the sort of like little rod inside of the SpaceX rocket. We put it in space, and it detaches, and then thing better work, right? Like you can't go up there and like tighten a bolt up, right? Like that's not a thing. And so the amount of time and attention you've got to put into like really thinking through what the gremlins could be, finding them, identifying them proactively, it's a very different approach. And it's, again, like I said a few moments ago, as an entrepreneur, that's the fun part, right? That's the learning how to do something new, mastering that skill set, and then putting that mastery, once you get it, hopefully you get it to work.
And I guess how important is that timeline? I mean, I guess SpaceX has maybe shown us that ambitious space-related projects don't always come together quite as planned or when they're planned.
Yeah, I think this is one where, again, I'm excited to learn like what the right balance here is, right? I think the right balance is not waiting 5 years, 10 years, 15 years, 20 years, as is the case with many important space programs. Like it takes a really, really, really long time for these things to see the light of day. And the problem with that is that people's careers are oftentimes, in a particular field shorter than that. You get sort of these weird effects when you wait too long to demonstrate stuff with hardware. Our approach is we want to be, one, a company that's more hardware rich. Two, we want to be a company that iterates in space earlier in our company's lifetime, because again, my viewpoint on it is until you do stuff in space, if you happen to be an aerospace company, you're actually an aspiring space company. And I would like to transition from aspiring space company to space company sooner.
Well, I think there are probably a lot of people, including potentially in this audience, who would like to work for your aspiring space company. You've hired so far 25 people from Lawrence Livermore Labs, Rivian, Cruise, SpaceX. What is the sort of talent profile?
Yeah. So first of all, two things. Number one, space is hard. This is going to be a very difficult problem to work on. If you are the kind of person that wants to work on stuff that's super, super difficult, please come and contact us because we are hiring. Second, the kind of people that work on this, there's a lot of physicists, right? There's a lot of people that are physics PhDs. There's mathematicians. There's mechanical engineers. There's optical mechanical engineers, right? It's not Silicon Valley without a bunch of software engineers too. So we do have software engineers. I don't have any AI buzzwords for this talk, but actually there's 57 seconds left, so I might have to talk about something AI related before my time is up. I'm gonna really struggle with that, so don't hold me to it. No, so it's interesting to kind of actually answer your question, right? There's a lot of specialization in fields that are not really represented in the large numbers that you see at the big employers around here, which is why you end up hiring people from places like Lawrence Livermore National Lab. And there's some fascinating people that come out of places like that and other places that have really deep technical knowledge, and it's fun.
A last question. So we have 17 seconds left. I think really interesting that you self-funded this initially, $10 million. You went on to raise $50 million, but you threw in some money there as well. Is that because people thought, successful entrepreneur, but, is like a guy from Robinhood, the right person to found a space company? Or was it, you wanting to have more skin in the game, or both of the above?
Well, I think one of the lessons from building Robinhood is that if you're trying to do something that's ambitious, you've got to have the right mix of capital to back the company. And I think in the case of Robinhood, the thing that was important was we had a really large demand for capital as we got further in the company's business. Space is very expensive as well, right? And so the way I thought about building the sort of network of people that were our early investors were people that some of them had seen what I did at Robinhood and wanted to bet on it again. There's a lot of net new investors as well. But I think the kind of thought process there was, if you want to do something that's going to have really big capital needs in the future, which, knock on wood, fingers crossed we get there, you've got to actually start building that investor base early in the company's life cycle and bring those people along with you through stuff that's working, a lot of the stuff that's not working, so they really deeply understand, as you as the founder do, what the opportunity is. Because again, space is expensive.
Great. Well, listen, I loved talking to you. I'm looking forward to seeing your constellation of laser beaming, solar powered, solar whatever in the future.
Exactly.
Exactly. Thank you so much, Baiju. So
Thank
great.
you.